Now that we've developed a basis in geometry, we're going to need a tool by which we can further develop our understanding. And what that tool is logic. So we're going to do a brief kind of introduction into what logic is and different ways that we can think about things. And just like always, we're going to start with some definitions. So the first thing we need to talk about is one of the two types of reasoning that we have. That first type of reasoning is called inductive reasoning. So inductive reasoning is just the process of finding a pattern in specific cases and then making a conjecture for the general case. So before we can fully define this, we have to ask ourselves what a conjecture is. So a conjecture is just an unproven statement based on observations. So what inductive reasoning is taking a look at some type of a pattern or system or a set of observations that we have. So finding a pattern in some specific cases that we've actually seen, and then trying to hypothesize or make a conjecture about what we think the general case is. So this conjecture, like we said, is just an unproven statement based on observation. So inductive reasoning is not how we're going to prove things. Inductive reasoning is kind of our starting point for which we can say, based on what I've seen, I think this is what's going to happen next. I'm not going to try and prove it. If we do, that's going to be our other type of reasoning. But I'm just trying to make an observation right now. And so we can't prove things with inductive reasoning, but we can disprove them, and that's what a counterexample is. So it's a specific case for which a conjecture is false. If I can find a counterexample for a conjecture that I make, then I can say definitively that it is false. However, just with inductive reasoning, I can't actually prove that thing to be true. So let's look at a quick example here. So an example would be, let's say I have the pattern. Let's see, I have the numbers 1, 2, and 4. And I ask you what is coming next in this pattern. And so what I've done here is I've looked at 3 numbers. Okay, so these are my specific cases. And I'm going to make a conjecture now about what I think is the general case. So what's going to happen next. So I could look at this and say, well, I think that the next number is going to be 8, and then 16, and then 32, and then so on. And so in other words, what my conjecture is that I think that this pattern is increasing by doubling each time. Now, that may be true. I don't know. I have no way of proving it. I have just looked at the pattern that's in front of me and taken a guess at what I think is next. And the reason I say it's a guess is because there's other options here. Maybe another option is instead making a conjecture that I think that these numbers are first going up by 1, and then by 2, and then by 3. And so the next number would actually be, maybe the next one's 7. And then I go up by 4, so then 11. And I go up by 5, so 16, and so on. So I'm making a conjecture here about, what I think the pattern is. Again, I can't prove it. It's just based on my observations. Now, what I can definitively say is not correct is if I were to say that, hey, maybe my pattern is that I'm just going up by 1 each time. Well, that would mean that my first number is 1, and then my next number is 2, and then my next number is 3. But here's the thing, is that I can definitively say that this is not the case, because I have a counterexample here that I tried to go 1, 2, and then 3, but the next number is definitely 4, and so I can show you that this is a counterexample to the conjecture that I made that I'm going up by 1 each time. So I can definitively say that this is not true, but just through inductive reasoning, I don't know. Maybe either of these could be the case. I'm just trying to make a conjecture about what the case might be. Now, the issue with this is that it seems a little bit wishy-washy, and that's fine, because I can't actually prove anything. But we have something to prove things, and what that is deductive reasoning. So deductive reasoning is a process of using facts, definitions, accepted properties, and laws of logic to form a logical argument. Okay, so this is how we are actually going to prove things later on, and every proof that we write will use each of these things or a subset of these things, but I will only draw from these things to actually make my proof and to make my argument. And using deductive reasoning, I can say that something is definitively true. I can prove it to be true, and it'll always be that case. Now, I'm not going to give you an example here because this is really kind of what our entire rest of the study of geometry is going to be about, is deductive reasoning, and so we'll see a lot of these. But this is the big one. This is the one that, moving forward, inductive reasoning is a nice starting point, but deductive reasoning is actually going to get us some things done. So, this is just a little introduction into logic and different ways of reasoning through things. That's going to lead us into more interesting things later on.